And this is our the fourth session. Tonight we will have two keynote speakers to give us fabulous speeches. And first we would like to welcome our keynote speaker, Professor Henri Achten. And Henri Achten graduated in 1992 from Eindhoven University of Technology in Netherlands. He was the first graduate to present his work using virtual reality. Actually, I even don't know in that time they have virtual reality. And in 1997, he received his PhD in engineering science for his research on knowledge encoding in architectural drawings. He continued as a postdoc at TUE and became a member of the New Design System Group. Here, he worked as an assistant professor in design theory and computing until 2010. In 2005, he joined the Faculty of Architecture and CTU as an assistant professor, where he leads the MoLab research program. In 2007, he received the title of associate professor, and in 2018 was appointed professor in architecture. Henri Achten is the head of Achten Pavlicic Novakova Design Studio, and the president of and teaches in master and PhD program in the school. He was vice president and the president of the European Association for Education and Research in Computer-Aided Architectural Design in Europe from 2001 to 2009. Henri Achten has co-authored over 100 publications on topics such as architecture drawings, virtual realities, collaborative designs, design research, and interactive architecture. Let's welcome Professor Henri Achten to give us the speech. Thank you.
Thank you very much for the kind introduction. It's a real honor and pleasure to present here on this conference. Thank you very much for the invitation. So the title of my presentation will be What is it interactive? And it will collect a number of thoughts on interactive architecture, as I have been working on that topic and thinking about it for, let's say, the past decade or so. Of course, when we think about interaction, then we think about buildings that change, that can adapt. And that is a thing that is very natural for architecture. In architecture, our buildings do change all the time. But the kind of change that we are looking at and associating with interactive architecture is, of course, quite recent. One of the oldest examples that I have encountered and also seen in person is from the 19th century. It's this building, the L'Hôtel Jacquemart-André in Paris by the architect Henri. Unfortunately, I could not find a video how it works, but what you can see here in the main hall are removable panels so that the hall can be extended. And even quite spectacularly, the outside facade towards the garden can actually be raised into the ground using pneumatic pistons. A little bit more recent is the well-known Rietveld-Schröder house by Gerrit Rietveld and Truus Schröder, where Gerrit Rietveld, by means of very cleverly produced wall panels, could make a highly flexible interior layout that people could change the organization according to their needs and how they want to use the house at that moment. A less well-known example from Czech Republic is the revolving auditorium in Český Krumlov. As you can see, it's a large cylindrical platform, which is actually the podium for the audience, and it can rotate. So that means that performances like operas can be done 360 degrees around the audience, and they are rotated up to the point where the action is taking place in the production at that time. One of the buildings that is usually denoted as the first example of interactive architecture is the project The Fun Palace by Cedric Price and Joan Littlewood. It was more an idea project because it was never realized, but the ambition was to create a staging center where almost everything could be changed and move. The escalators, the podia, etc., etc. As I said, this was always remained a paper project, but 10 years later, Cedric Price was able to realize, you could say, a more reduced version of the Fun Palace, the so-called Interaction Center in Kentish Town. It unfortunately no longer exists, but it has a number of container-like modules that can be moved throughout the building to different locations. This building from 1987, the Institut du Monde Arabe in Paris by Jean Nouvel, was actually a building that was realized in the time when I was an architecture student. So it had really a very big impact on me as a starting young architect. The interactive facade using diaphragms to open and close the windows according to the daylight was for me a very inspiring example at that moment. A couple of years later, we move more and more into these technologies that can enable these changing elements in architecture. And a groundbreaking project in 2009 was the Decoy by Mark Goulthorpe, Mark Burry, and many other people who worked on that project. It works by a series of pistons on which these triangular facade elements are positioned. And by moving the pistons perpendicularly to the wall, you can create these animated movements in the facade. Obviously, during the years, the most ubiquitous example of dynamic facades or facades that can change are media facades. And here is a very nice example from the Kunsthaus in Graz by Peter Cook and Colin Fournier. An example that is a little bit less obvious is the Mediatek building in Barcelona by Cloud9. It uses these ETFE pillows, which you can see on the right in the facade, as a shading system for the daylight. It has a triple layer construction where the central layer can move due to different air pressures in the chambers. And both layers have a fritting on its surface. So when you can move the central layer towards the interior layer, then actually the frittings cover each other. And in that way, you can decrease the opacity of the facade. Another very nice example is the Expo in Korea by Soma Architects, where they use a very elegant system of bending facade panels to create this opening, closing facade system that almost looks like a breathing organism. A well-known example from the past decade are the Al Bahar Towers in Abu Dhabi, where you have a truly highly dynamic changing facade. Again, it's a shading system that can react dynamically on the daily conditions. A bit less well known, I guess, is this building in Tehran, in Iran, the Sharifi House by Next Office. It offers these rooms that can rotate according to the winter and summer conditions in the country. So in the winter conditions, you want to have as much daylight as possible and profit from that. In the summer conditions, when it's actually too hot, you simply rotate the room so that it blocks out the immediate sunlight. Here more example of an interior application of interactive technology, the Ori Studio, which is actually a spin-off from the MIT Media Lab, which has actuated furniture elements in the room that can move, and in this way you can create many different layouts and uses of quite limited space. And the final example that I would like to show is the shed, which was completed in 2019 by Lillas Covidio and Renfro Architects, which is this very large building envelope that can move out over the square, and in that way offer many different uses of the building and the square for performances and so on. So when we look at this very, very short history of dynamic architecture, then we can see things like moving wall panels or moving escalators, modules, opening, closing facade elements, shape-changing walls, media facades, ETFE pillows, screwing panels, opening, closing piston panels, rotating rooms, robotic furniture, and a moving building envelope. So the key to all of these projects is adaptation. In some way, the strategy of that adaptation is where the parts of the building rearrange to better suit some kind of need. So the action of the building follows a certain need of the users, or vice versa, where actually the parts of the building rearrange simply because we can do it. So there then the need would follow the action. It's in particular the second strategy where we are investigating lots of technological possibilities. What can be done with these new materials, new technologies, new control strategies. And I think that's a very important part of developing interactive architecture, because they actually show us, and you could say open our eyes for what can be done. And without these concrete examples, without such concrete experimentation, it's very hard to come up with new ideas. So this part of strategy is actually quite important. It is argued by Robert Kohlenberg that actually this adaptation, this being flexible, is something that is already a part of architecture for a very, very long time. He actually claims that because through the majority of history, mankind has led a nomadic lifestyle. So therefore, having flexible, lightweight structures that can be taken apart and transported to a different location is actually something that we have been living in for the majority of time. And the fact that we are settled in cities on fixed locations is actually a more recent phenomena. Nevertheless, these ideas about flexibility, adaptability have become under, you could say, renewed scrutiny in the past decades. There is this really very nice study called Time-Based Architecture that tries to make an inventory of these technologies and show all kinds of architectural approaches, how to think about this flexibility. And in the bottom right, you can see a quite spectacular experimental house, the Next 21 project in Osaka in Japan, which was a demonstration house prototype to show how maximum flexibility could be realized. And I would say that the foundation of methodologically thinking about adaptation, about flexibility, was started with John Habrake when he wrote in 1961 his book on supports and infill. He basically outlined these first notions about how can we make buildings that are sufficiently flexible and adaptable for people who are going to live in these buildings. So with these notions of support and infill, he came up with the theoretical foundation and also the methodological foundation, how to work with these ideas. This later was turned into the so-called Stichting Architecten Research, a research association, which later transformed into the open building movement. And they really focused on developing a methodology and a set of design techniques, even graphical representations, to help architects think about this problem. How do we provide support structures that have actually enough flexibility for people so that they can, in the future, change their houses with a minimal effort? this is a very important background because John Habrake founded the Faculty of Architecture in Eindhoven, where I studied. And he was the founding father of the Design Methods Group, where I did my diploma work and later also my PhD research. This was all in a certain time period, the 60s, where this thinking about changeability and adaptability was also a kind of a cultural movement, a certain statement, a new vision about architecture that tried to, rebel is probably not the right word, but tried to react against certain tendencies in the society. And of course, these drawings, for example, by Ron Heron, the walking city on the ocean that you see over here, was this very evocative image that tried to give some expression to these ideas. And it's of course very tempting to take these images literally, to think about these huge structures walking over the earth and having a minimum impact on the planet. But of course, one should take that more in a metaphorical aspect, and not take it too literally. If you take it too literally, then it could look something like this clip from the movie Mortal Engines, where you actually see these moving cities crawling over the landscape. And in fact, when you visualize it in this way, that dramatically, then you can see that the idea as such should not be taken too literally. That is not really what these drawings were about. It was not the message of the architectural thinking at that time. So let's return to the question, is it interaction, all this adaptability that we have seen up to now? Here is an example of a PhD project that was done at our faculty by Vasilia Abramovich, and which we were very happy that she could conclude and continue her work at the Bartlett School of Architecture with Rouari Glynn. And together with other people, she created this very beautiful interactive installation, The Edge of Chaos, which in my view is something that comes very close to notions of interaction. So in the past years, we have collected many, you could say, concepts, terminologies about what interaction or these kinds of systems could actually be. So for example, we have building automation system, which means monitoring, control of mechanical, security, fire, flood safety, and so on, usually applied to commercial buildings. We have smart homes, which actually are building automation systems, but for the residential area mainly. We have sentient buildings, where the building tries to form some internal representation of the building. We have adaptive buildings, which are very typically the smart facade buildings. We have dynamic buildings, where most parts of the building are actually physically moving parts, so that the interior changes a lot, which is very similar to kinetic architecture. Then we have intelligent buildings, we have portable buildings, and finally, we have also interactive buildings. So what then is an interactive building? What is the key distinction that sets interactive buildings apart from all of these other types and terms that we saw just now? For me, the crucial difference is that there is a dialogue between the system and the user. So an interactive building engages in a meaningful information exchange with the user, and it can anticipate and initiate change in the building based on some internal representation of that user, on some kind of understanding what the needs of the user are. And there is an information exchange between the user and the building, so that it's not just purely a reactive system. An automatic sliding door is a reactive system. A person comes close to the door, the sensor notices it, it opens the door, the person passes through the door, and after that the doors close again. There is no dialogue, it just reacts on certain impulses registered by the sensors. So for me, that is not interaction. interaction, there should really be a meaningful information exchange. Now, why would we try to do that? If we look at regular buildings, then we can see, of course, that all buildings are placed in a certain context which has some kinds of conditions. These conditions are plotted here on this S-curve through a minimum and a maximum. It can be temperature, it can be amount of daylight, it can be humidity, it can be a function representation. And if you have a building and you don't do anything else, then that building will offer a certain level of comfort, a certain amount of function within a margin area of these conditions. When the conditions are such that the building by itself cannot offer that comfort or function anymore, then we need to have additional measures to make the building perform again. So very often we do that by adding heating, cooling, shading, changing aspects of the space, etc. With that, of course, we have to invest energy and materials to make this happen and work. If we use passive technologies, then we try to extend this comfort and function zone without adding these additional measures. But very often that means that we have to invest a large thermal mass for energy storage, and we need a lot of embodied energy. With interactive buildings, we try to do the same, but with, you could say, a reduced amount of material or embodied energy. So we have the building again, it functions in certain conditions. And when we notice that the conditions change, that they are moving outside our comfort zone or outside a certain functional use, then we simply adapt the building so that it fits again into that point. So through these changes, we try to catch up, you could say, with the changing conditions of the environment, but without using too much embodied energy and too much thermal mass collection. It does mean, of course, that our change investment, the energy to change the building, becomes much larger than in usual solutions of buildings. And of course, it's the question if we can come up with a trade-off in which this investment of change energy is actually lower than the embodied energy that we would have in traditional technologies. Other reasons why we would need that buildings change dynamically are, for example, social changes. Our roles in society, in the family, between people, in our social groups, they change historically. Our roles change, the positions that we have, the responsibilities that we have, and therefore the spaces that support these processes and these roles also should change. This is, of course, a quite slow change, but nevertheless, it's a change that happens. And certainly within one generation, you can observe such changes. More dynamic, more faster changes are buildings that are multifunctional and that can offer many different kinds of activities under that building. For example, you have sports stadiums that also function as venues for concerts or for trade fairs. So there you also have to be able to change the layout of the building, the seating. If you have sports stadiums, then you can maybe change the seating arrangement to have a different pitch in the center, etc., etc. So here the changes are very often dictated by the change of activity. Another group of buildings that are highly dynamic is where you have high volumes of travelers or people who are in transit. Typical examples are airports, train stations, bus terminals, etc. There, of course, the major goal is to help people who often are for the first time in a location like this to orient themselves, to find their way in a safe and fast manner, to have all the goods transport into the building very fast and efficient, And of course, if there are security issues, then you should help to get the people out of the building also in a safe and fast manner. And the final example of buildings that actually require a lot of adaptability, flexibility, and I would say interactivity are care and needs facilities. They have to facilitate support and spaces for people that need help, assistance, and medication. Very often they are there for hopefully a limited amount of time for the first time. So these are spaces that they don't know. They are in stressful situations. So the spaces and the architecture should really help them with that process and that phase in life that they are in these buildings. So as you can see, there are many reasons to have interactive architecture. There are reasons of dynamic performance, where the adaptability reduces the amount of measures that we have to take to make the building fit for its use. We have changes in society, how people act and behave. We have buildings with multiple uses, a varied portfolio. We have dynamically changing environments and multifunctional buildings. But of course, it doesn't mean that every building must be interactive. We should really very carefully think about when is interactivity really necessary. So when does it provide a benefit? And in many cases, it could be that we don't need it at all. So it really takes careful consideration when and how to do that. For us as designers, it means that we have to change the way we think about architecture and how we organize our design processes. We have to move away from a mechanistic viewpoint of interactive buildings and think much more about the objects, the people, the processes, and the world in which these objects are situated. And key to understanding that and key to designing that in a successful way is to make more organic design models of these interactive buildings. We need to come up with comprehensive models of interaction. We need to come up with complex models that can simulate and predict the behavior of buildings and people. So these kinds of active or proactive models really are part of the solution. Without those models, I think it will be really very, very hard to successfully design interactive architecture. Now, the big question is, how can we create such buildings without requiring the user to use these remote controls or to push buttons the whole time? I think for that, the answer lies into a convergence of three key technologies. The first technology is Internet of Things. So Internet of Things basically is like the regular internet, where in the regular internet, a uniform resource locator or URL gives you the location to a file or a computer located on the internet. But Internet of Things actually combines that with physical objects. So it combines physical objects with a retrievable digital representation of that physical object. Very often these are sensors, actuators, RFID tags, smartphones, etc. The second technology that I think is key to these developments are wearables. So wearables basically very often used in with health activities or sports activities are sensors and computers that you wear very close to your body. They monitor things like your heart rate, your movement speed, conditions like air humidity, etc., etc. So very often they are associated with health and fitness sector. But basically what they do is they simply monitor you 24 hours a day. And the third technology that I think is key to all of this is cloud computing. So cloud computing basically virtualizes the computers on which we are performing all this processing of information. So it's no longer located on one specific computer, but it's actually a network-based service, and you actually don't know where the computer is that runs all your services or processing power. You actually don't care, but as long as you have access through it, through an internet connection, you can scale up or scale down the computing resources that you need according to the need that you have at that point. So what kind of picture emerges from this? So what we will see that in our daily lives and environments where we act and live and work and rest, we have our wearables that monitor our state and well-being. The objects, the things, the building components that are surrounding us, they are communicating through the Internet of Things. And not only our immediate environment is doing that, but the outside world is doing that as well. All this data goes to the cloud, which then has the additional intelligence and processing power to infer our condition, the context that we are living in. It can think about, okay, what are we needing at the moment? And all of that together basically results into a communicating ecosystem that can actually form the backbone of interactive architecture. So what it actually does is, yes, interactive architecture needs to understand the user, but we don't want to ask the user the whole time, what do you want? You have to push this button, or you have to do this or that. We don't ask the user, we simply ask the wearable, because the wearable knows what the user is doing, how he or she is feeling, whether they are comfortable or not. We can gain peripheral awareness of the context through Internet of Things. And with cloud computing, we can get the support infrastructure that can control all these things. So in my view, and of course, this is a hypothesis, this is not something that is proven, but this is my hypothesis that this will happen, is that this actually will form, this conversion of technologies will form the technological context to create truly interactive architecture in the buildings. So what should we design then? Obviously, any technical system that is interactive consists of 4 parts. There is some sensor array that can look at the environment, what is happening. Then there is a controller that decides on the basis of this input what is happening and what should be done. The controller sets some actuator in action that can actually make a change in the physical world. And the actuator reacts on a material system that does something. But all of these are technical components. They enable interactivity, yes, that's true, but they do not really drive what the system should be doing. They do not steer the goals. They do not realize interactivity, they enable it. But what we do need to define, what we do need to design is behavior. What should the building be doing and how should it be doing? From my point of view, I've looked at this question, so how can we define this behavior of interactive systems? And I try to solve it through the concept of attitudes. And an attitude for a physical system that has to be interactive has 2 components. One component is a worldview, which is, you could say, the main motivation, what that system tries to achieve in the world. And the second component is the interaction view. What kind of style of interaction should the system have to communicate with the users? So we can look at many different worldviews. At the moment, I have defined 5, and that is, of course, a question of discussion. Should it be 5? Is that not too much, or is it not enough? But at the moment, this is the list that I could come up with. So many different worldviews. For example, one that is very largely focused on performance. Optimization of certain performance criteria, like amount of light that comes into the building, or reducing the amount of energy, or visual relationships, material use, etc. Another worldview could be rather to look at sustaining. No, I want to reduce my resources. I want to have a low energy footprint, or I want to look at the life cycle support. Another worldview could be servicing, where you actually try to optimize the amount of efficiency of the building, or the comfort of the user, or to reduce the efforts that they have in using the building. Symbolizing could be yet another worldview, where actually the focus lies on giving meaning supporting rituals in life and in society, or to provide motivation for the users. And finally, entertaining, which is more about show and dynamics and pleasure, giving this wow effect to the people who are looking at the building or who are using the building. Then with the interaction styles, so according to the literature, there are basically 4 interaction styles. The first one is called instructing, which is focused on teaching someone how to do something. So we are learning something or informing someone, showing how to do things. Another interaction style is conversing, which is more about establishing a dialogue and having information exchange and building a mutual narrative. A third interaction style is manipulation, where it's all about handling things, making things work, very typically in command-action chains. And the fourth interaction style is exploring. So that's more about search, discovery, finding, and wandering. And as you can see, if you put these worldviews and interaction styles into a matrix, then each combination of these worldviews and interaction styles results in a certain personality, in an attitude. So if you combine performing and instructing, then you have a certain attitude that tries to act like a trainer. If it's more about sustaining and instructing, then it's more like a mentor. If it's about servicing and instructing, then you could say it has more the character of Hal from the movie 2001. If it's more about symbolizing and instructing, then it could be an icon. Or if it's entertaining and instructing, then it could act more like an idol. So as you can see, as you fill in these cells of worldviews and interaction styles, then the unique combination of each of these results in a certain personality, you could say, or how I define it, an attitude of the building. And as you try to come up with a representative image of each of these attitudes, then you can imagine intuitively that each of these personalities actually is a different kind of person with which you could interact, and you could imagine that your relationship with that person or a system that has the character traits of that person will actually react and respond to you in a different way. Now, the question, of course, is, this is a hypothesis, this is a theory, and it has to be tested out in practice. So that is obviously the next step. But what they actually try to do with these attitudes is that they actually help you when you are designing an interactive system to put certain emphasis on key parameters of that system. So these different attitudes define different ways of behavior. They put different emphasis on response times for actions that the building can take with you. They have a different focus, what they find important in their dialogue with the user. They have a different style, and therefore they also require different resources in order to realize these attitudes. In short, they have different characters. Now, one final thought about thinking about these attitudes and interaction and architecture is, of course, that if we look at buildings, then buildings by nature and definition are very large collections of components. And it's the components and the systems that make up the building that are interactive. It is not the building itself. It would be a mistake to talk about interactive architecture or interactive buildings as if there is one package that would do the whole job for the whole building. I think that is a misconception. And we should really be understanding that it's about a multitude of systems, a multitude of applications that are reacting with each other. And there's another consequence, and that is, of course, that the interaction with the building is spatial and temporal. With spatial, I mean that you move through the building, you go through different locations in the building. Thus, it's not one point where the interaction happens, it's a number of points, a number of paths that you take through the building. and thus it's also temporal. Some things happen first, then another thing happens, then you have the next, and so on. So what you are actually doing when you are interacting with a building is that you construct an experience in time and in space. And that is what an interactive architecture is about. So we have to move from an idea that we can do the job with just one interactive system. That is probably not true. We need a whole collection of interactive systems. And through these ideas of attitudes and personalities, we can try to give them a more unified character. Because I think what is really very important is that interaction is not a series of disconnected, separate, isolated events and encounters with technology. At one point you encounter one technical system, it does this, it does that. Then you move on, you encounter another interactive technology. It behaves in a completely different way, does completely different things. And there is no line, you could say, that connects these into a certain experience. I think an interaction should really be a meaningful series of events that supports our path in life. In short, an interaction should be a narrative. We should be designing interaction narratives when we are thinking about interactive architecture. So to summarize the points of my lecture, so we first looked at a number of buildings through history that change. We tried to come up with a number of defining issues, why buildings change, why do they adapt, and then define interaction as interactive architecture as one of many different ways how adaptable buildings can be defined. Then I hypothesized that the convergence of Internet of Things, cloud computing and wearables will form probably the backbone on which we can actually design these interactive buildings without resorting to too much control and intrusion of the user. And I also hypothesized that, okay, if we want to create interactive architecture that has a certain character, then we can do that through the definition of attitudes. And very, very importantly is to not forget that the whole encounter with an interactive building should be a storyline, a narrative that you have with the user. So with that, I would like to conclude my presentation. Thank you very much for your attention. So if there are questions, then I will be happy to answer them.
Thank you.